In a previous lesson, I covered how to find TTFB, time to first byte. TTFB is one of several metrics that we use to measure the performance of our websites. In this lesson, we'll review the most important performance metrics to consider when building and testing your website. I'm going to assume that you already know why we should test our websites for performance. And at the end of this lesson, you'll have a clear understanding of the metrics, which will hopefully help you create a testing plan for your own website development. Now, we could create a list of 50 metrics and combinations of metrics to test, and we both go crazy trying to test and track them all. And it's really not necessary to overdo it. There are also some softer metrics too, which are based on user perceptions of the performance of the site. We'll cover them later when we talk about perceived performance and user empathetic metrics. The following 6 metrics are some big important ones that you want to keep an eye on while you are developing and performance testing your website. They are page weight, time to first byte or TTFB, start render, load time, speed index, and total number of requests. Those are the ones we're going to cover, so let's get started. Page weight is the total of a single page's assets, the HTML, CSS, JavaScript, images, etc. Page weight is typically measured in kilobytes, but it can be measured in megabytes as well. And one useful attribute of the page weight metric is that it's independent of servers and infrastructure, and it's something that we can easily measure as the project progresses. Because page weight is independent of infrastructure, we can measure it accurately whether we're developing locally on our machine or working on a staging server or the production server. If the project you're working on is a redesign, you can collect some page weight data from the existing site and some competitor sites, and that'll help you frame what your target page weight should be. Now let's look at how we can find the page weight. To determine the page weight, we'll use the Chrome browser and its developer tools. For the website, we're going to use the sample site that Pixel and Tonic provides as part of a demo for the Craft CMS. I've done other courses on the Craft CMS. You can check those out at majingo.com/learn or majingo.com/craft. And this is just a sample site that we're using. I have it up and running at happylogger.majingo.com. And you can check that out and run these tests along with me if you would like. So the first thing is we want to find the page weight. To do that, we use the developer tools in Chrome, and we access those under View, Developer, and then Developer Tools. And that'll pop up either a pane at the bottom of your browser or off to the side, or it could even be its own window, depending on how you have it configured. So now it says to hit Command R to reload, which we need to do so the developer tools can capture information about this page. And you can see it's filling up our timeline here. We can see our page loading. We want to make sure we are on the network tab when we do that. And now we can look at the bottom here under the second option on the bottom status bar. It says 2.0 megabytes transferred. So that is our page weight. So we know that this page is 2 megabytes. And if we look at our assets, let me just make this a little bit bigger so we get more space here. If we look at our assets, which are all listed here, it defaults with the main document being first, but the main document isn't always the biggest. So if we sort these columns by size with the largest first, now we can get a good view of where this 2 megabytes is coming from, starting with the largest asset, which is this background image on the home page. Not surprising that that is the case, and we can see that that is 192 KB, and then it goes down from there. So if I was looking at this, I would say, okay, I got 2 megabytes in page weight. That's probably a little bit on the heavy side, but again, it's all relative. I would look then at my assets here and start to determine how I can address that page weight. Or I might look at it and say, this page weight is acceptable based on the performance budget that I set as part of this project. The next metric is time to first byte, or TTFB for short. TTFB is the amount of time, measured in milliseconds, that it takes for the browser to get the first byte of information from the server after it makes the request. And this measurement time starts after the DNS lookup. Unlike page weight, TTFB is environment specific and not something you'll probably test locally during development. You can, but there's not really a good reason to do that. TTFB is also the first metric that I review when someone complains of a slow site. A long TTFB doesn't necessarily mean that the other metrics are within normal range, but it is a metric that isn't always something you can fix yourself. And that means it has a different path to resolution than performance issues that we web developers can fix. A really slow TTFB cannot be fixed by improving site performance in other areas. That initial page request will still be slow. Let's look at Chrome again and find the TTFB for this site. So again, we're back at the sample site for finding TTFB, and we are using the developer tools. We have this open. One trick is that you can use Option Command I in Chrome on the Mac to open and close the developer tools without having to access the menu. So that's Option Command I. So again, the developer tools pane will be open either on the bottom, the side, or in its own window. And we want to be working again in the network tab. And now I'm going to reload again to get a fresh report. And this time we want to go to our main document, which the developer tools will default to first unless we sort otherwise, and click on that. And now when we look at this, I'm going to make this just a little bit bigger, we can see that we have this waiting here. It says waiting TTFB, and this is the measurement of our time to first byte, which is 338 milliseconds. So this bar here is showing us TTFB in relation to other items here, like the DNS lookup and the initial connection. Now we then have to decide whether this TTFB is long, too long, or perfectly fast like we want it. And really that's going to depend on a lot of things. There's some standards that people have on how fast the TTFB should be. This feels a little slow to me, almost a half a second, but we can kind of decide relatively within our project where that TTFB falls. The total number of request metrics is how many times your web browser has to request assets and resources in order to complete the loading of the requested page. Each request adds some overhead to the page load and some, depending on the size of the resource requested or latency of the remote server, may slow down the page disproportionately. The total number of requests is easily calculated using just your web browser. Let's use Chrome to calculate it for our sample site. To find the total number of requests, we will keep working in the Network tab in the Developer Tools. And let's go ahead and reload again to get some fresh data. And now the total number of requests is just to the left of our page weight, or the total number of megabytes or kilobytes transferred, and is right here. And it's 31 requests, and that is counting everything here in this list. So now we know that the server is being asked 31 times for data from the browser, and there's actually those 31 different connections happening. So one tip on this is that we want to make sure we measure the maximum request that this page will make, because we always want to look at the worst case scenario, which would be the visitor's first visit to the site. We want that first visit to the site to be exceptional. So to make sure that's happening, you always want to have disable cache checked in the developer tools, and this will turn off the browser caching while the developer tools are open. If we're trying to measure page weight, page load, the number of requests, we don't want to take into consideration caching until maybe that's something else we want to measure with caching. Okay, like on a second visit, we know that it'll be this speed or this number of requests or this page weight. So we want to make sure we have this checked for these initial tests so we get accurate numbers. Start render is the measurement of time from the page request until the first page content appears. This is content other than an empty white page that you see. The name start render is just a name. It's not really anything official, and different people and different tools call it different things. It's only important to know that start render is the time it takes to go from a blank white page to something that shows progress in displaying the page. Before the start render can happen, a few other operations precede it. You have TTFB, downloading, processing the HTML head, initial page layout, and rendering. And why is start render an important metric? Because it signals to the site visitor that the page is loading. The content at the time of start render will be incomplete, but it's an indicator that things are moving forward. In a few minutes, I'll cover perceived performance, and start render is an important one for how your page load speed is perceived by the visitor. To measure start render, we're going to introduce a new tool, webpagetest.org. Webpagetest.org is run by Google and offers an impressive suite of tools to test your website. You submit a URL, and the tool will return an impressive report full of metrics for you to review. To measure start render, we're going to go to another tab at webpagetest.org where I ran a 9-run test on our sample site. And there are a couple different ways of looking at start render. The first one is here on the performance results table at the top of the test results. We can look at the start render column right here, and I get 2 results because we're basically looking at our results for the median run. And the first view we get 3.685 seconds, and for the repeat view 3.185 seconds, and that's run 6. We'll click on that and look at our film strip view, which is another way to be able to visualize this, because here we get the visualization of the rendering of the page, and you can see as I scroll, the timeline moves down here as well. So we can scroll through and that moves as our assets load. I can also increase the thumbnail interview to 1/10 of a second, so if we wanted to get more. And as you can see, this stays fairly blank. There's a little bit of rendering in here. It's kind of hard to see, but there is a little bit here. And then it pops into place at 3.2 seconds. If I go to another test, this is a test I ran actually on Majingo.com, you can see how the start render works here. You can see how it's starting. So we're getting visual clues that the page is loading, and then it's all completely visually loaded, like that. So that's how the film strip view gives you an idea of what's happening, down to the 1/10 of a second. So a really handy tool for understanding the start render time of your site. The load metric for performance testing might have different meanings depending on who you talk to and which test suite you use. Let's review the different variations and then settle on one for our purposes for this lesson. In the parlance of webpagetest.org, load time is, quote, the time from when the user started navigating to the page until the document complete event, usually when all the page content has been loaded. If we look at our webpagetest.org results again for our sample site, the first column is load time. So here's where we can get a view of the load time for this test run. For the first view, we had 3.439 seconds, and then for the repeat view of run 6, it was 2.912 seconds. So this is where we can measure the load time or review the load time for the site. So we have 2.9 seconds is what I would call this. It's for the median run for the repeat view. So we'll go with that number. We can also look at the load time using the Chrome developer tools. So if we go back into Chrome here and we go to the network tab again, if we look here, we have our load time of 4.57 seconds. And that was the load time here. Let me reload. And again, you can see it'll pop up here once it is done loading. So that time was 5.56 seconds. So we're able to measure the load time. The nice thing about using webpagetest.org for doing this is that it'll give you the median result. Let's say you run 9 tests. It'll give you the first view and second view of the median run, so you can kind of understand based on several tests sort of where your page load falls. It's always going to vary slightly from page load to page load, so we're looking for the median number in this case. Unlike other metrics we've already covered, speed index is a tool-specific metric. Speed index is calculated in milliseconds, and you'll only find this metric on webpagetest.org. Let's take a look at how that works. Earlier, when we measured start render time using webpagetest.org, we reused the film strip view to see at which frame the page began to render. We could go down to the 10th of a second and start to see when things started to render. And I mention this because this film strip view is what webpagetest.org uses for speed index. This is how one way it measures when the site is visually complete. So this sub-metric, let's call it, visually complete is measured by calculating, quote, the unrendered portion of the page over time. And I really like this description from this webpagetest.org documentation for speed index, which I'm just going to highlight right here and then read off, is the first sentence under introducing speed index, which says the speed index takes the visual progress of the visible page and computes an overall score for how quickly the content painted. So speed index is a score that webpagetest.org calculates for you, and again, from site to site or from improvement to improvement over the course of a project, it gives you a nice way of measuring progress based on this one metric on webpagetest.org. And if we look at our test results, you can see our speed index is the fourth column, and first run we had 3,700 and second run was 3,200. The idea here is to keep our score for the speed index as low as possible. We don't want it really high, we want it as low as possible. The lower the score, the better. For all the details on how they calculate the submetrics around speed index, check out the detailed write-up in the webpagetest.org documentation. Speed index is what I call a user empathetic metric, meaning that it measures something that directly affects your site's visitors. Compare this to other metrics like the total number of requests, which on its own doesn't really directly impact the user. That means a user wouldn't notice between 20 and 25 requests. The user wouldn't really notice those 5 requests. With the review of some major metrics complete, let's step back and take a look at how these metrics really impact the website visitor. There are metrics for the sake of metrics, and then there are metrics that actually matter to your visitor, your customer, or your users. Your typical site visitor won't care about the number of requests it takes to complete the page load, but she will care about the perceived performance of that page. How does it feel when she loads the page to read your article or buy your product? Is it fast? Is it slow? Is the majority of the page loaded quickly? Is the part of the page that contains the content or information that she seeks there quickly? Or is it an obvious wait to see that add to cart button? Or there's one cynical metric, does it feel as terrible as it does trying to load an article on CNN.com? Scott Gell of the Filament Group coined this idea of perceived performance. A more useful benchmark for evaluating page speed from the user's perspective is the time it takes for a page to become usable. You often hear developers refer to this as perceived performance because it refers to the performance metric that is most easily perceived by the naked eye and likely to be most meaningful metric to our users. Another way I like to classify performance metrics is by those that are user empathetic. Empathy in website design and development is an important trend, and not without its detractors, because it shifts our focus as creators of the web away from gazing down at our tools and technologies and forces us to keep the user experience front and center. User empathetic metrics are similar to what Gell described in the quote. The performance metrics that I think are most user empathetic are the following: start render and speed index. Both of these metrics are combo metrics, meaning that their measurement is influenced by other metrics, like, for example, TTFB. And that's a wrap for this lesson on web performance testing metrics. I'm working on a full course covering web performance testing beyond just metrics, and if you'd like to be notified when it's ready, please drop your name and email address in the form at the end of this video. To learn more web design and development techniques, go to majingo.com/learn. Thanks for watching. I'm Ryan Ireland from majingo.com, and I'll see you in the next lesson.